Now let us look at various types of polynomials based on their degree. So we can have linear polynomials, quadratic, cubic, biquadratic, constant polynomials, etc. Let us look at each one of them in detail. First we have linear polynomial. So a polynomial with degree of 1 is a linear polynomial. For example, 4p minus 9, 6q plus 3, 2m plus 5. So these are all linear polynomials. And why is it called linear? So whenever we draw a graph, a linear polynomial forms a straight line. Say we have the equation y equal to 4p minus 9. Now this is a linear equation and this is a linear polynomial. So the graph of this, if we plot it on the xy axis, would be a straight line. So this is a straight line with a slope of 4. So we'll understand more about what do we mean by slope and how is a slope 4 in the later lessons. Now let us look at a quadratic polynomial. So a polynomial with a degree of 2 is a quadratic polynomial. For example, 5x squared minus 3x plus 2. So this is a polynomial with a degree 2. So this is a quadratic polynomial. Say we have 7 minus 4y minus y squared. Again, it's a polynomial with a degree 2. So this is also a quadratic polynomial. Similarly, z squared minus 6z plus 8 is also a quadratic polynomial. So why is it called a quadratic? So because the graph of a quadratic polynomial is a parabola, which is a U-shaped curve. For example, say we need to plot the graph of y equals 5x squared minus 3x plus 2. So first of all, this graph opens upwards because the coefficient of x squared, which is 5, is positive. So you will understand in detail about what I am talking in the later lessons. So this is x-axis and this is y-axis. Okay, and the plot of this y equal to 5x squared minus 3x plus 2 will be something like this. Okay, now this shape is a parabola. So this is we'll have this kind of a U-shaped curve which opens upwards. So we'll understand more about parabolas in the later classes and in the later lessons. You just need to remember that this is a quadratic polynomial. What is a cubic polynomial? So a polynomial with a degree of 3 is a cubic polynomial. For example, if we have 2r cube minus or plus 6r square minus 4r plus 1. So this is a polynomial, degree is 3, so this is a cubic polynomial. 9s squared or 9s cube minus 5s minus 3. So this is also a cubic polynomial because the degree of the polynomial is 3. Now for cubic polynomials, the shape of the curve when plotted would be S-shaped. it will be in the shape of an S. For example, let the polynomial be 2r cube plus 6r squared minus 4r plus 1. So let y equals to this particular polynomial, and we know this is a cubic polynomial. Now if we try to draw the graph of this polynomial, in this case this would be the r-axis and this would be the y-axis. The shape of this particular polynomial would be something like this. It would be an S-shaped curve, and it would be a smooth S-shaped curve. So you need to remember that a cubic polynomial, when plotted, gives us an S-shaped curve. Next, we have a biquadratic polynomial. So a biquadratic polynomial has a degree of 4. So for example, 3t to the power of 4 minus 2t cubed plus 5t minus 7 is a biquadratic polynomial because the degree of the polynomial is 4. Similarly, 8u to the power of 4 minus u squared minus 6 is also a biquadratic polynomial. So the term biquadratic comes from the Latin word. So bi means usually 2 in Latin, and quadratic means squared. So this means squared and this means bi means 2. So basically it is a polynomial of degree 4, which is essentially a squared of a squared. So it is a biquadratic polynomial. Now we have a constant polynomial. So a polynomial with only one term, which is also a constant, would be a constant polynomial, and the degree of a constant polynomial is 0. For example, say 10 is a constant polynomial. There is only one term and it's a constant, and the degree of this is 0. Similarly, minus 4, 6 and so on, these are all constant polynomials. So a constant polynomial can be written as k multiplied by x to the power of 0, where k is the constant. And since x to the power of 0, we know that anything to the power of 0 is nothing but 1. So this is k multiplied by 1, which is k. So we can write a constant polynomial in this form, that is k multiplied by x to the power of 0. So far we have seen various types of polynomials. So we have seen linear polynomials, that is degree is 1, and this forms a straight line. So these linear polynomials, they are used in calculating speed, distance and time relationships. So we use them in physics, and later on in some examples we will see how we can use them in speed, distance and time relationships. Next we have what are quadratic polynomials. So we have seen that for quadratic the degree is 2 and the curve is a parabola. And where do we use quadratic polynomials? They are used, say, to model projectile motion, which is, say, the path of a ball when it is thrown in the air. So that would be represented using a quadratic equation, a quadratic polynomial. Then we have seen cubic polynomials, which have degree 3, which are represented using a S-shaped curve. Now these are used in 3D modeling, and they are also used for designing curves in engineering. Next, we have seen biquadratic with a degree 4. Now, these are used to represent higher order relationships. We will see them later. And these usually appear in, say, we have if any kind of advanced physics, and even in economics for modeling complex systems, we use biquadratic curves. Then finally, we saw a constant polynomial has a degree of 0, and because it's a 0, it just represents a fixed value